Hello, everyone, and welcome to the limit of a function. So, in this subtopic, we're just going to discuss the intuitive definition of limits, like what do we need to know from it. Then afterwards, we'll just have some examples. All right. So, without further ado, let's now begin. So, hold on. So here we have the intuitive definition of limits. According to Herman and Strang, when all values of the function approach the real number, as the values of x approach the number a but not equal to a, we say that function or fx has reached its limit as x approaches a, and that limit is L, which is this one. So you see, last time, uh, when it comes to finding the limit, it's not about finding the exact value. Rather, it's about what? The value that you are approaching to. Just like what it mentioned here, when all values of the function approach the real number L. So the answer that we found earlier is not the exact value, but rather the value that you are approaching to. All right? So yeah, the way how you pronounce this is the limit of a function as x approaches a is L or is equal to L. Again, the limit of a function as x approaches a is L or is equal to L. So here, we can just, let's just say, describe this representation in the easy way. Remember this one, math is fun. So basically, it is a special way of saying ignoring what happens when we get there. But as we get closer and closer, the answer gets closer and closer to a value or L for this case. All right. So it's not about, again, the exact answer, but the answer gets closer and closer to. That's it. All right. So let's have some examples. Let's try this one. All right. The limit of 3x minus 1. So let's start first with the left. All right, left. Let me just say LHS or left hand side. All right. So we have our x values and we have our f of x values or y values rather. All right. So here, the way how we pronounce this is the way how we describe this is the limit of 3x minus 1 as x approaches 3. All right. So now let's find values that are closer to 3 from the left side. So the values that are closer to 3 are 2.9 and 2.99. But let's start first with 2.9 because 2.9 is close to 3. So let's substitute 2.9 as your x value. So let me take a look. 2.9. 3 times 2.9 minus 1. Okay, so here you will have the answer of 7.7. All right, now let's make it even closer. 2.99. All right, by the way, let me take a look if it's 2.9. Okay, so now what if we have 2.99? So 3 times 2.99 minus 1 will give you 7.97. All right, 7.97. Now let's get even closer. So 2.999. So let's take a look. 2.999. We have 7.9997. And now let's stop until here since this is the only values that we can reach, but it's up to you if you can reach like more than 5 decimal values, all right? But yeah, so here the answer is 7.9997. So you see the values here are closer to 3, right? So the result, the results are 7.7, 7.97, 7.997, 7.9997. So as the x approaches 3, it approaches to 8. All right? Because you see, if you get the approximate number of this, what would be the answer? It's 8, right? Because these values are approaching to what number? They're approaching to 8, right? So that's for the left. We're not done here because we're going to what? Find the right side. Okay? So what will be on the left should be also on the right. So on the left, it's approximately 8. Now, let's go with the right hand side. So here, we will get values that are closer to 3. Let's just say 4.1. Wait, no. No, not 4. I mean, 4 is close to 3, don't get me wrong, but I want closer to 3. 3.9. Yeah, there we go. 3.9. 3.9 is close to 3. So let's substitute 3.9. So here, 3 times 3.9 minus 1, you will have 10.7. All right, so we have 10.7. Am I right? All right, okay, 10.7. But I want it closer. 3.1, much better. Because 3.1 is close to 3. In fact, it's actually closer than 3.9. You get me? So let's substitute 3.1. I think that's far better. Okay, so 3.1, 3 times 3.1, it's 8.3. Okay, so it's 8.3. Now let's make it even closer. 0, 1. What will be 0.01? We'll have 8.03. So if we, that would be 8.003. So if we substitute 8.001, we will have 8.0003. So what can we observe? So that means as the x values approaches 3 from the right side, we have these results. And these results are approaching to approximately 8, right? So that means on the right side, it's also 8. Since the left and the right are the same, therefore the answer here is 8. Right? The answer here is 8. All right? So yeah, we're done at this. Next, the limit of x squared minus 1 all over x plus 1 as x approaches negative 1. So we will do the same thing. All right? So we have the x and the f of x. I think we've answered this before, but at least we have a practice, you know what I mean? So yeah, let's start first with the left-hand side. All right? So we will start with values that are closer to negative 1 from the left side. So here on the left side, okay, since we have negative 1, what's next to negative 1 on the right? It's 0, right? Then on the left, if we continuously proceed to the left side, we have negative 2. So negative 2, negative 1, 0. So that means we will start at negative 1.9, right? Let's start with negative 1.9 since it's closer to negative 1. So now let's substitute. So here, negative 1.9 squared, am I right? Yeah, okay. So negative 1.9 squared minus 1 all over negative 1.9. I mean, yeah, okay, yeah, sure. I mean, mine plus 1. So negative 1.9 squared minus 1 Okay, so we have the result of negative 2.9. Yeah, negative 2.9. But I want closer because this one's a bit far. Don't get me wrong, it's still close to negative 1, but I want it closer. So I think it's negative 1.1, right? So let's use that. So negative 1.1, let me just change that. Negative 1.1, then yeah, we will have an answer of negative 2.1. All right. So let's make it even closer to negative 1. So the answer here, wait. So we will have, hold on. Sorry, I was using calculator, forgive me. That's the only way for me to get the values. So we have negative 2.001. So if I'm going to use negative 0.001, so we will have negative 2.001. Let's have one more. So let's substitute with this one. So we will have negative 2.0001. So these are the x values that approach to negative 1, but from the left side. All right. So here, as you can see, as we let our x values approach to negative 1, we have this. Then we have these results. And these results, as we continuously get closer to negative 1, it is approaching to what result? Negative 2. All right. So that's on the left side. All right. So that's on the left side. Now I hope the right side is also negative 2. All right. So if you're asking me, what happens if they're not the same? We will find it out later. All right. So now let's proceed to the right hand side. So getting x values that are closer to negative 1 from the right side. So what are the numbers closer to negative 1 from the right side? Well, we have negative 0.9, right? So let's substitute negative 0.9 in here, negative 0.9 squared minus 1 all over negative 0.9 plus 1. Wait, let me just check. Negative 0.9, okay. So here we will have negative 1.9. So let's make it even closer to negative 1. So let's try this, negative 0.99. So let's take a look. It's negative 1.99. 99. It's 99, not 4. So let's make it even closer. So we will have negative 1.999. And I think we're going to stop right here. I think this is enough. Because we already know at what value it's approaching. Okay, so negative 1.9999. So here, as we have x values approach to negative 1 from the right side, we have these, right? So as we use x values that are closer to negative 1 from the right side, we have these results. And these results are approaching to what number? To negative 2, right? Negative 1.9, negative 1.99, negative 1.999, and so on and so forth until it reaches negative 2. So the right side is negative 2. With that being said, the answer here would be what? Would be negative 2. All right, since both sides approach to negative 2. So that is good, right? So we have one more example. No, actually there are two, but I would rather leave one as for your practice, right? Let's start with this one. 1 all over x. All right? So let's go to the left-hand side. So x, then f of x. No, wait. Let me fix that line. Okay. So 0. So what are the values from the left side that approach to 0? Well, we have negative 0.1, right? Because you see, we have 0, then we have negative 1, we have positive 1. So here we have negative 0.9, then negative 0.5, then negative 0.1, then exactly 0. And here on the right side, similarly, we have 0.1, 0.5, 0.9, then 1, and so on and so forth. So therefore, we will get we will start at the value that is closer to 0, but starting from the left side. So we have negative 0.1. So let's now substitute this one. Okay, 1 all over negative 0.1. So here we will have negative 10. Okay, I see the pattern here. So what if we get closer to 0? So we have negative 0.01, we will have negative 100. Now, if we get closer and closer to 0, so we will have 3 decimal place. So we will have negative 1,000. And we get even closer. The answer is negative 10,000. All right. And last not the least, we have negative 100,000. Wow. If you would observe this one, if you have a negative answer here, negative answer, negative x values approaching to 0, you have this as a result. And you see, these results is approaching to what number? I don't know. Because you see, as we let 0, uh, as we let 0, no, wait. As we let the x values gets closer to 0 from the left side, the values of function is increasing. All right? So it's increasing, increasing, so on and so forth. So with that, we can say that it's approaching to negative infinity, right? I mean, it does. On the left side, it approached negative infinity because maybe if we're going to substitute a value with this, but let's just say the decimal values, let's just say it consists of more than 6 decimal values, I think we will reach negative 1 million above. You get me? So here, not already approaching to what number, but rather, it's about, like the amount of number it produce. You get me? So therefore, your left is approaching to negative infinity. You get me? Now, how about on the right? All right, let's try on the right side. Let me erase this one. So wait. This is once again 8, negative 2. Now on the left, we notice it's negative infinity because again, it's not about approaching a number, but it's about what? It's about what? Getting large number instead, larger numbers. Now let's start first with approaching a number. Let's start a number that is approaching to 0, but from the right side. So 0.1, right? So if you're going to substitute 0.1 here, you will have 10. All right, and I can see already the pattern here. If I put 0.01, I have 100. If I put 0.001, the answer would be 1,000. If I'm going to have 0.0001, I will have 10,000. If I have 0.00001, the answer would be 100,000. So this one is just similar from the left-hand side. It's just that the difference is that we have positive values. Yeah, all right. But the similarity here is that they do not approach to what number, but rather it produces a large amount of number from 10, 100, 1,000, 10,000, 100,000. So if this maybe reach like, let's just say it has more than 6 decimal values, maybe it will reach to 1 million plus above. So we can say that it's approaching to positive infinity. Because again, it's not about approaching to a number, but rather the number is increasing. So therefore, on the right, it's approaching to positive infinity. Now, what did we observe from this two? Both sides are not the same. You get me? I mean, they are infinity, yeah, but they aren't the same. So, what are we going to do if the left and the right are not the same? The answer would be D and E. Or it could be L, D, and E. What does that mean? It means that your limit does not exist. Okay? I would like to include limit here so that it would complete the whole sentence, like limit, hold on, limit, then does not exist. There you go. All right? But yeah, it's up to you, DNE or LDNE. But commonly, we would rather just use DNE. It's simple. So DNE stands for does not exist. Because you see, both of them are not the same. You get me? So therefore, the answer here is what? Does not exist. So for your assignment, try this on your own. This one. The limit of x minus 1 all over the square root of x minus 1 as x approaches to 1. All right? So take a screenshot of this one, or you can just pass backward for like 10 seconds. All right? And yeah, that will be all. So see you soon, guys.